Okay, let's look at the swivel base drawing. It, by all appearances, it seems rather simple, but there's a few tricks to dimensioning and constraining that I want to show you on this. And then we're going to look at some more of the parametric dimensioning so that you could resize the object based on one or two inputs. So start with a metric part file, and we're going to start with a sketch. And I'm going to put it on the front plane, the XY plane. I'm going to start with my circle that will be the left end of the object. And it's a radius 30, so I'm just going to drag it out and get it close. I don't want necessarily to have to be exact because we're going to play with some things here, okay? And I'm going to come with a horizontal line across here, another horizontal line across the bottom, and make them equal length. And then we'll do the arc at the right side. And then it has a couple of horizontal lines coming off. And notice I'm picking up the constraints on those. And let's put the hole in that's on the inside. Now let's add a couple of constraints here. And I want to do a horizontal constraint from the origin to the center of each of the holes. Okay. And let's see, other constraints. That's kind of got those in the right place. We need these arcs right here, and while they're tangent to one line, they're not tangent or quadrant intersects with the other lines. So let's start with just drawing a circle out here with no constraints applied to it already. And then let's put a tangent constraint onto those lines. And then a coincident constraint from the circle to the endpoint. All right, and now let's trim. Okay. And let's, just for giggles, let's do some equals. Well, that's parallel. I want to go equal constraint with those two arc. The radius would be the radius of those arcs. And I want to do an equal constraint for each of these two lines here. And see, that shifted those things around. Oh, we're not tangent there, so let's go tangent. All right, and I'm going to show my constraints so I can see tangents there's equals horizontals, tangents equals horizontals. Okay, now let's apply some dimensions. And I'm just going to pop dimensions in here as it shows in my drawing. And so we'll go center that to here. Center that to there. Center to center. And then I need a hole in the middle of there. So let me trim that out, and let's put a circle for the hole. And I got a constraint there. And we'll go ahead and apply a dimension to that. Okay. Now, if we can do parametric dimensions so that things change in relation to each other. So if we knew that we're going to manufacture, these parts, but we may need different sizes based on a particular instance. I don't know, let's just say, for example, the diameter of the hole here would drive, if we need a bigger hole, then the part has to be bigger, of course. And so we could make these things adjustable based on the diameter of a certain hole. Okay. So let's, since this is what we've got here, let's start with this hole right here, and it should be a diameter 20. All right. Now, the outside radius of this is equal to the diameter of the hole. So I need to change, I've got a diameter dimension there. So I'm going to delete that and come back and do another dimension because I want a radius. And now I want to make it equal to that. And I think if I do times 2, no, it should work fine. So there we go. Because I got one was a radius, one was a diameter. Okay, so those two would become equal. This one would be half of this. So we'll choose that and divide it by 2. This dimension would be 3 times that diameter. Okay, and this one is going to be 48. There's not much we can do to we could mathematically do it, but we'll take this one and make it equal to that one times 2. And this one would be equal to our whole times, I think, oh, that's still a diameter dimension also. So let's delete it and make it a radius. So that would equal that times 1.5. All right. Oh, we still got this arc here, which would be radius 15. We'll keep that at 15. All right, and now it tells us we're fully constrained. So a nice thing about this is that if we need, say, we need a bigger part for whatever thing, we can just open this file up, save it as a new file, come in here and edit that to, we'll say, 25. And you see it adjusts the size of several things. Now, granted, our overall length didn't change, but we could, you could certainly play with that and make it work. So let's finish that sketch and extrude it. It has a base thickness of 10 millimeters. Whoop, let me just select my profile. Okay. And then we have a boss that's right here. And so I'm going to go with a primitive here. So I'm going to go with a cylinder on that surface, coincident to that point. And it has a diameter of 30. So the cylinder's asked me for a radius, so I'll say 15. And now my extrusion height is another 5 millimeters. So you can see what we did there. Now we want to put a hole through the center of that. So I'm going to go hole command, choose that surface, choose the edge to make it coincident, or concentric, sorry. And my diameter is a diameter of 20 millimeters, and we want it through all. Awesome. And so there's the part. It gives you a little introduction to parametric dimensioning, so that you change one thing, it can change multiple things, it can update. So you want to save this, your last name, Swivel Base, and submit it in the Dropbox in Blackboard.